we're going to do a little more of like trying to find the equation when you're given points. Okay, so let's say we're doing like trickier ones. Okay, so we're given 2 points, okay? This time though, they don't give us the y-intercept, right? There's no 0, comma, a number. We just have 2 random points on the line. So it's going to be a little bit trickier. There's going to be a little bit more steps to try and find the equation. Equation for this line. Okay, so, but what we can do is find the slope. Okay, so we got our y equals mx plus b, and we're going to try and find the m and the b, right? So we can figure out the slope, because the slope is just how do I get from one point to another. Okay, so change in y, 7 minus 1, right here. Change in x, 3 minus 5. So we get 6 over negative 2, which is negative 3. Okay, so we've got the m part, negative 3x. Now we need the b part. Okay. So they didn't give us the y-intercept. You can graph it and try to find it. Just the only way, you'd have to make sure you use like a grid and a straight edge to graph the points so that it lines up perfectly, or you use like the computer to graph, or you can. So if you think about it this way, remember these are points given to us that fall on top of this line. Okay, that means every point is a solution to the line, right? So that means I have an x and a y, 2 x and y's right here. I can actually plug them right in. So you can pick any one, we'll do both. So let's do this first point here, 3, 7, and I'm gonna plug in the 3 to x and the 7 to y in this right here, and what I'll be left with is how to solve for b, right? So y is 7. I know the slope, I figured it out, it's negative 3. X is 3. And I need to solve for b. Okay, so then I'm trying to solve for b. 9 plus 7 is 16. So b equals 16. Right, because remember, these points are solutions. That means I can plug the points in to my equation to help me solve for b. So let's try it with the other point, just to double check. So 5, 1, right? So y is 1. We know the slope was negative 3. X is 5. We're going to try and solve for b. And look, we still get b equals 16. So you can pick whatever point, because remember, all the points that are given to you are all part of this line. They're all solutions. So it doesn't matter which point you decide to pick. You can plug it into x and y and solve for that b, and we got 16. And there we go. So the equation for the line that falls on these 2 points, 3, 7 and 5, 1, is y equals negative 3x plus 16. So that's kind of just a slightly more complicated example for trying to find an equation. The last one I want to cover is what happens when you have an equation that looks like, maybe not 0. This. So if you remember the y-intercept form, there's no x in this equation, right? That means that the only way to get rid of the x is if m is 0, right? And we have a number here. That's going to be our b. Okay, because 0 times x would just give us 0, and you'll get y equals 5. So that means that our slope is 0, and our y-intercept is 5. And if you remember, what does the slope of 0 look like? Slope of 0 just means a nice horizontal line. Okay, so if I were going to graph this, y equals 5, that's our y-intercept. And essentially what this equation is telling us that it doesn't matter what x is. X can be anything, because no matter what, y is going to be 5. Y doesn't care what x is. If x is 3, y is still 5. If x is 6, y is still 5. If x is -3, y is still 5. It doesn't matter. So y is always 5, so you get a nice horizontal line. Okay, so what happens when you have x is a number? Okay, so if we're thinking y equals mx plus b, essentially, I'm going to try and rewrite this in terms of x. Sorry, I'm trying to find a way to explain this in a way that's not confusing. I think that's going to confuse you. I'm just going to wipe it out. I made it too confusing. Ignore it. I'm very sorry. Let's just graph it and we can see. Okay, so similar to what we did before, right? Y equals 5. So it was saying no matter what x is, y doesn't care. Y is always going to be 5. Same concept here. It doesn't care what y is. It's good to label your x and y axis in this case, so you're like, which one's the y axis, right? This is x equals -2, so it's like y can be 3, x is still -2. Y can be -5, x is still -2, right? So you get a vertical line, and if you remember rise over run, right? So rise over run, it would be like we go up 1 to the right 0, right? Up 1 over 0. Remember, we can't divide by 0. So therefore, the slope is undefined. Okay, slope is undefined. That's why it doesn't fall into this really nice form here, because this is an undefined slope. You can't really multiply things that are undefined. But if you were going to like write it out, right, I want to get rid of the 0, so that means I multiply, I'm going to move the b. Multiply both sides by 0. 0. Right, so you get like a really weird undefined thing because you can't actually divide by 0, so that's why there's no nice equation in slope-intercept form. So it's really just about thinking about in terms of x is -2 no matter what. It doesn't matter what y is, and you're going to get that vertical line. Okay, so we've pretty much covered I've covered like vertical and horizontal line graphs, how to figure out equations from points, just from given points, how to figure out equations when you know the y-intercept, right, and then you can determine the slope, how to figure out equations from looking at a line, right, lots of how to write things in slope-intercept form, And just, yeah, we learned pretty much all the major components of graphing a linear equation, an equation with an x and a y, right? And so now the last thing I will cover is graphing inequalities, which is not as complicated as it